Dissociation is the process of decomposing an ionic solid into its component ions. Okay? So we take an ionic compound like sodium chloride, and we break it apart into its different ions. Right? Because when we dissolve it in water, right, the water will attack, certain parts of the water will attack the sodium, certain parts of the water will attack the chlorine, right? Because remember, according to electronegativity, a molecule of water, right, the oxygen is slightly more negative than the hydrogen, which means when we dissolve sodium chloride in water and it breaks apart, it ionizes, right, or dissociates, breaks apart, forming ions. Notice the Na plus, the Cl negative. The Na plus, because it's positively charged, what part of the water is going to surround it? The oxygen. Right? Because the oxygen, right, is slightly negative. And opposites attract. So when we have now the chloride, what part of the water is going to surround it? The hydrogen. So we've got the hydrogen part. Because the hydrogen part is slightly positive. And the opposites attract. Okay, this is what we call the hydration of these ionic compounds. So whenever we dissolve something like that in water, this kind of dissociation is what occurs. So, aqueous means the ions are hydrated. The ions is surrounded by water molecules, what we have there, right? Whenever we said we saw aqueous, AQ, it means it's dissolved in water. How does it dissolve? Well, the ions of the ionic compound actually break apart into their positive and negative, their cations and anions. So, water molecules are electrostatically attracted to the ions. This is called the solvation of ions. So what's occurring here, right? There's an electrostatic attraction, right? Opposite charges. Okay, we have the Na positive, okay, the cation here, which is attracted to the oxygen part of the water molecule. We have the chloride anion, which is attracted to the hydrogen part of water. And it's what helps to dissolve these type of ionic compounds. Now, when ionic compounds dissolve to produce ions, the process is typically called dissociation. Dissociation of ionic compounds occurs when water molecules pull apart the ionic crystals, right? With that example, the ionic crystals are the Na and the Cls, right? The positives and negatives. This occurs due to the strong attractions between the polar ends of the water molecule and the positive and negative ions within the crystal, right? Remember, this attraction of the polar ends, right? Remember, oxygen, we said, is slightly negative. The hydrogens are slightly positive based on the change in electronegativity, right? That's how we can tell. And then the positive and negative ions, right? Something that is ionic, right? If we have something that is ionic, we know ionic compounds deal with combining a metal with a non-metal. Metals have a positive charge, non-metals have a negative charge. Water molecules then surround the positive cations and negative anions in a process called hydration. But it doesn't surround it in the same way, right? Remember, the oxygen part is what because it's slightly negative, attracted to the positive cations. The positively charged hydrogens are attracted to the negatively charged anions of your ionic crystals. So, dissociate the following ionic compounds. So, take a moment, copy out these examples, and actually dissociate them based on their respective ions that they would form. Looking at the first example, NH4Cl, what is the cation? So the cation is the positively charged aspect. NH4. What is NH4? Ammonium ion, which has the +1 charge, right? So NH4 with the +1 charge, right? And it's aqueous, right? Because what's surrounding it right now? No, the water. What part of the water?
The oxygen.
The oxygen is what's surrounding, right? Which means the hydrogen part of water is going to be surrounding its other counterpart, which is the Cl negative, right?
That's all we have to do.
And that's all you have to do. Right? So we had the oxygen part, right? Because oxygen is slightly negative, is going to surround the ammonium. The hydrogen part, because it's slightly positive, is what's going to surround the Cl negative. Let's look at the next example. PbSO4 in aqueous. Pb, not 2, positive 2, right? Pb plus 2. Right? Because remember, what was the charge? And now, I really don't want to go back, but just to kind of reiterate. Remember, what charge does sulfate carry? It's a -2, right? We don't see any little subscripts here. So which means they must have been canceled out. Right? Which means they were simplified. Right? Which means that the Pb had to have been a +2, and the sulfate, which is obviously the -2. So the Pb is a +2. So what part of the water surrounds it? The oxygen, right? So the oxygen part of water surrounds all, okay, pretty much all the cations, right? Cations, positively charged. The hydrogen part of water surrounds all the anions when we dissociate these ionic crystals. Okay, so we have Pb +2, and what is our anion? SO4, -2. Right? Notice aqueous. Right? Really important, guys. Please do not forget the charges, because if I don't have this, we don't know really what part of water is surrounding it when it's in that hydration. So that's really, really important. KOH. K positive, 1, and the hydroxide is OH negative. Now, what kind of compound is KOH? Base, right? So this is a base. So not only is it dissociation here, but this is also the ionization of a base. And we'll look more about that later on. The last one, what is the cation? Sodium ion, right? But how many sodiums do I have? I have 2, which means I put down 2 Na pluses. Right? That's where the 2 comes in. And how many sulfates? Just 1 sulfate, right? Which is SO4 -2 aqueous. And as we said, the oxygen part of of water is what surrounds all the cations. The hydrogen parts of water during this hydration surrounds all the anions in our dissociation.